Module 10 will discuss the construction of jointed plain concrete pavement, JPCP, over an existing flexible asphalt pavement. Jointed plain concrete pavement, JPCP, over an existing flexible or asphalt pavement is a construction process or strategy also known as white topping. FDOT has had limited experience with rigid overlays. Successful projects have been constructed in 1989 on US 1 and 2009 on I-95. FDOT has also had some unsuccessful projects, and they include the 1997 on I-10 ultra-thin 3 and 4 inches thick concrete overlay, where this technique of ultra-thin white topping, UTW, was tried on a truck inspection station, but it was not successful. The FDOT research report BC 354 43rd RPT. The website link is provided in this slide. To evaluate the applicability of UTW in Florida, FDOT constructed a test pavement at the Ellaville Wait Station along I-10 in North Florida in 1997. So the UTW pavement consisted of 6 sections, test sections with varying panel dimensions and slab thicknesses. The performance of all the test sections was less than ideal. It showed some early cracking on the concrete surface, and concrete rehabilitation had to be scheduled for 2002. It was determined that for the way stations subjected to frequent applications of heavy truck traffic, the UTW technique is probably not appropriate rehabilitation alternative. A picture of the report cover and some pictures of the report are also shown in this slide. If other types of overlay using white topping are tried, they should be considered experimental and coordinated with the State Materials Office. That is covered in Module 11 and also in the Rigid Pavement Design Manual, Chapter 13. A rigid pavement overlay of an existing flexible pavement structure is basically designed the same as a new rigid pavement. That was already covered in Module 3 and is also in Chapter 3 of the Rigid Manual. Treating the existing flexible pavement as an asphalt base course over granular base. The required overlay thickness are determined using the asphalt base design tables found in Chapter 3 or with the Pavement ME software. The variables and standard design inputs are the same as listed in Section 2.2 of the Rigid Pavement Design Manual, see Module 3, or Section 2.2 of the recommended input. These are the variables to use for the design. For reliability, I'll refer to the Rigid Pavement Design Manual, Table 3.2. Traffic loading forecast, the equivalent single axle loads easels obtained from the District Planning Office, and the climate region that is found in the Rigid Pavement Design Manual, Figure 3.1. Similar to a new construction design, use the Rigid Pavement Design Manual Appendix A for Florida-specific inputs to pavement mechanistic empirical ME software. Also refer to Rigid Pavement Design Manual Section 2.2. They include initial smoothness, the IRI, terminal smoothness, IRI, terminal faulting, terminal cracking, 28-day PCC compressive strength, coefficient of thermal expansion, the CTE, asphalt base, thickness after milling plus new asphalt overlay, lime rock base, stabilized subgrade type B, resilient modulus, road bed soil resilient modulus, your MR, and the joint spacing and the truck lane slab width. It's permissible to leave structurally sound existing asphalt pavement for use as a base layer for concrete. However, milling and resurfacing of the existing pavement may be used to minimize grade increases, adjust roadway cross-sections, remove wheel path ruts, and provide a uniform longitudinal profile. The rigid overlay thickness is very sensitive to the asphalt base thickness due to the bonding condition and relatively high asphalt dynamic modulus, but it is not highly sensitive to the lime rock and other underlying granular layers. When milling an existing flexible pavement prior to the rigid overlay, it is desirable to leave at least 3/4 of an inch of asphalt over the base throughout the project to protect it from traffic and rain. The mill surface should be overlaid with at least 1 inch of type SP traffic level B. The total asphalt base thickness for input to the pavement ME design software is the thickness of the existing asphalt pavement after any milling and the new asphalt overlay. It may be feasible to place JPCP overlay directly on a milled surface. Now, this has not been tried in Florida, so if the designer desires to try this, it should be considered experimental and coordinated with the State Materials Office as outlined in Chapter 13 of the Rigid Pavement Manual. Drainage and other design inputs and details. For edge drain systems, Standard Plans Index 446-001 for rehabilitation, covered under Module 1 and also in the Rigid Pavement Design Manual, Chapter 4. For joint details, Module 5, Rigid Pavement Design Manual, Chapter 5. For shoulder design, Module 6, Rigid Pavement Design Manual, Chapter 6. And for pavement widening, Module 7, Rigid Pavement Design Manual, Chapter 7. This concludes Module 10, JPCP Overlays of Asphalt Pavement. You're now ready to proceed to Module 11, New Technology.